Don't be scared if you get a question like this in your exams, because it may look horrible, but actually, once you know how to deal with these questions, they're not too bad. So the setup with this question is you have this V shape, y equals modulus of x. Remember, modulus of x just means y equals x on the right hand side and y equals minus x on the left hand side. And then we've got this horizontal flat line, y equals k. K is some random constant, positive constant. What you can do with this triangle that we've kind of formed here is create rectangles. You can create rectangles that kind of touch the triangle like this, or you could do, let's do one in blue now. Let's do something like this. So you can create all of these rectangles here. So the question is, what is the maximum area of a rectangle that you can create? So again, find the maximum possible area of a rectangle bounded by these two curves. So in maths, when you want to find the maximum or the minimum of something, firstly, you need to get a formula for that something. If you don't have a formula for that something, how are you going to maximize or minimize it? So we need to get a formula for the area of that rectangle, or a general rectangle. So I've just drawn out the diagram again. Sorry, I did make a bit of a mess with this diagram here. But anyway, so I've drawn a random rectangle like this. And what you can do, you can call the x value there x. Remember, x equals 0 is there. Just call this x there. So that means that this there is going to be negative x. And we know that because we have a modulus graph, and the left-hand side of this modulus graph is just a reflection of the right-hand side. So we've got minus x there, x there. So do you see that the base of this rectangle is going to be 2x? So let's make a note of this. So we've got this base here of 2x. So how are we going to get the y coordinates? We need the y coordinates to get the height, because obviously what we're trying to do is we're trying to work out the area of this rectangle, or get a formula for the area of a rectangle. What is the area of a rectangle? It's base times height. So we need the height, this red height here, right? So firstly, let's work out the y coordinate here. So we know that this V shape is y equals modulus of x. Plug in x equals x into the formula. We get that y is equal to x. So this y value, x value is x, and the y value is also x as well. Now, what is the y value up here? So the y value up here, as we know before, is k, y equals k. So that there is k. So this height from there to there of this rectangle is going to be k take away x. So height is k take away x. So now what we can do is multiply the base and the height together. So area is equal to that. I'm just going to expand the brackets. So the area is 2kx minus 2x squared. So now we've got a formula for a general rectangle trapped between these two lines. Right, quick ad break. If you're year 13 Edexcel, or your child is year 13 Edexcel doing A-level maths, I have 3 spaces remaining to work with me one-to-one and have A-level maths coaching tuition. So just click the link in my bio. You can go to my profile, you click the link, and then you can fill in the questionnaire and then book a call with me using the link on my website. So again, go to my bio, click that link, book a call, and then we can discuss. So we know that this is the area of a general rectangle, and we want to maximize this area. So in maths, when you want to maximize or minimize quantities, the technique that you can always use is differentiation. Because when you differentiate a function and set it equal to 0, you find stationary points, and you know that maximum and minimum values satisfy stationary points. So that is the idea of this question. So you differentiate your area with respect to x. Remember, k is a constant, so when you differentiate this here, this first term, you get 2k, and then bring the 2 to the front, take away 1 from the power, 4x there. And again, because we're trying to find a maximum value is a stationary point. When you want to find stationary points, you make your derivative equal to 0. So now you can add the 4x to both sides. You get 2k is equal to 4x. Divide both sides by 4. You're going to get that x is equal to a half k. So if x is equal to a half k, then that means that this x value there is minus a half k. So your base is going to be k. So remember, the base is 2x, so 2 times a half k. So your base is k. So that base there must be k. Now the height, we know that the height is k take away x from our formula before. So we do k take away the x value. The x value is half k. So the height has to be a half k for this to work. And so the maximum possible area for a rectangle that we could possibly create trapped inside these two shapes, the maximum area must be base k times by height half k. So the maximum area is a half k squared, and that's our answer. So as an example, if k was, let's say, 10, then the maximum possible area, if that was y equals 10, that flat line, maximum area would be 50. That's your maximum possible area that you can have trapped inside the two shapes. Now, if you want a bit of homework, and I would recommend doing this because this question here was actually a past paper question from AQA. So you've got a circle, and it's exactly the same as the previous question. The question is to maximize the area of a rectangle. So the rectangle must touch the circle. It must be bounded by the circle. Find the maximum possible area of a rectangle trapped inside this circle. X squared plus y squared is equal to r squared. So the radius is r, center is at the origin. Find the maximum area of a rectangle, the possible maximum area. Let me know in the comments once you've done it. Now, to be fair, just a word of warning with that question, you do need to have seen the chain rule and the product rule to do that question. So just be aware, if you've not seen the chain rule and the product rule, you won't be able to do that question. But if you have, you can go ahead and do that. Now, the question may actually ask you to go and show that it is a maximum, because a stationary point could be a minimum as well. So the question may actually ask you to go and prove that it is a maximum point, and this is what you would do. So from the question, we found that the area was this, and we differentiated it to get dA by dx. So if you want to prove that this area that we found here, this half k squared, is a maximum, then what you need to do is you need to differentiate again, so to get the second derivative. So if you differentiate this again, see how you get nothing here. Differentiate 2k, that's just a constant, you get 0. And then differentiate the minus 4x, you get a minus 4. So the second derivative is always negative. So therefore, if your second derivative is always negative, then obviously that is going to give us a maximum area, right? Because this x value, when you plug it into the second derivative, well, you can't really plug it in because it's already negative. So that second derivative is always negative. The curve is quadratic, which means it's a concave curve. So obviously with this area formula that we have here, it's a quadratic shape, isn't it? So it's a negative quadratic like this. So you're going to have a maximum point. So that's quite clear. So you just say now, therefore, area equal to half k squared is maximum. So if you do have any questions, do let me know.